So the objective of the experiment number 2 is to perform the speed control of the separately excited DC motor by varying the armature voltage using single phase fully controlled bridge converter. Okay, so we can use the MATLAB or SciLab, any software for this. Consider a 200 volts, 875 RPM, 150 ampere separately excited DC motor, which is having the armature resistance of 0.06 ohms. It is fed from single phase fully controlled rectifier with AC source voltage of 220 volts 50 hertz. Okay, since it is a fully controlled rectifier, so we will be having four rectifiers. Okay, and this is the this AC source voltage is given. So this is the RMS voltage, and when we will be multiplying this by root 2, we can get the maximum voltage. So we have to calculate the firing angle for the rated motor torque and 750 RPM. So consider this diagram for single phase fully controlled rectifier. It is AC source is feeding the DC motor, separately excited DC motor, and since it is a single phase fully controlled, so four thyristors are given. So first of all, the at the rated operation, the EMF is 200 minus IARA, which is the drop across the armature resistance. So we will get the EMF equal to 191 volts. Then we will calculate the EMF at 750 RPM. So we have to apply the formula E1 upon E2 is equal to N1 upon N2. So three data is given. The fourth can be calculated as 163.7 volts. Now the formula of armature voltage is VA is equal to E plus IARA. From this, we can calculate the armature voltage. Okay. Now for the fully controlled rectifier, the voltage, armature voltage formula, which is calculated based on the firing angle, is given by 2 Vm cos alpha upon pi, where alpha is the firing angle. Okay. So Vm, we can calculate Vm as Vm is the maximum voltage, but the RMS voltage is given as 220 volts. So we will be multiplying that by root 2 to get the maximum voltage. So here in this equation, only one alpha, which is the firing angle, is the unknown. Rest is given, so it can be calculated easily. So it is alpha is 29.3, which was requirement of the first part. Similarly, the on the same grounds, the minus 500 volts is given. The minus sign indicates that now the machine is rotating in the reverse direction. Okay, so again the EMF is calculated on the above formula, E1 upon E2 is equal to N1 upon N2. Then the armature voltage is calculated, same formula is repeated, and again the firing angle is calculated as 120 degree. But in the third part, the firing angle is given and speed is to be calculated. So when the firing angle is given as 160 degrees, then we can calculate the armature voltage using the formula 2 Vm cos alpha upon pi. Using this formula, we get the armature voltage as minus 186 volts. Then using the VA is equal to E plus IARA, where IARA is the drop across the armature. We calculate the E from here. Now the formula E1 upon E2 is equal to N1 upon N2 is applied to get the speed at this firing angle. Okay. So this programming part is also very much similar to that which we have performed in the experiment number 1. All we have to do is to give the input command for the parameters or the variables which are known, and then we have to apply the formula, then we have to display the output using the disp command. Okay, so when all these three parts are over, then we can draw the graphical output as desired in the numerical. Now we will be applying the formula of armature voltage, which is the 2 Vm cos alpha upon pi. So in the MATLAB, here pi is written as pi, and as I have explained in the last lab also, a cos d, it means that cos inverse, and d stands for the angular value in degrees. Okay, and pi is given as pi in MATLAB, but if you are using SciLab, then this pi should be replaced by 3.14, and all these comment lines which are beginning with percentage should be replaced by the double slash, or you can altogether remove that also, because these comment lines are for the benefit or for the help of the programmer. It has to do nothing with the programming output. Okay, so similarly we will be giving the input of second speed and getting the EMF, armature voltage, and getting the its display. Okay, now in the third part we are going to supply the firing angle. It is denoted here by C. So C is 160 degrees. So when we are giving this angle value, then applying the armature voltage formula, which is 2 Vm cos alpha upon pi, we can get the armature voltage and then the EMF, and then applying the formula E1 upon E2 is equal to N1 upon N2 to get the new speed, which is the third part of the numerical. Okay, now we have to plot the graph. Okay, so this plot is between the armature voltage and speed. So plotting will be when n is varied from 20 to 180 degrees. So n here is a firing angle. So all these formulas will be depending upon this firing angle n. So in the formula within brackets, round brackets, this n is given. Okay, so armature voltage formula is defined, EMF formula is defined, and the relationship between the EMF and speed is given. Then we can plot, give the plot command between the armature. So for loop is used here. So for loop will begin with the for command and end with the end command, and it is case sensitive, so it should be used in small letters. Then we have to plot the graphical output between the armature voltage and the speed. We can define the marker size, line width, line style as explained earlier, and also we can give the color coding. We can use 110, 011 to get the different colors. Similarly, we can use the different line style as dash or dotted and give the line width. And rest of this portion, it is applicable to only programming in MATLAB, where we can define the marker at different values of n, and its shape we can define. It can be given as a square or round, etc. So X labeling and Y labeling can also be planted in the MATLAB graphical output. Similarly, if we want to give some title or text message can be given by giving the x and y coordinates of the output. Now let us see the output, which is this is the output of the MATLAB. So first of all, based on our programming, we will enter the value of armature resistance, armature current, source voltage, rated voltage of motor, rated speed, etc. Then we will get the value of EMF. Then based on the formula of E1 upon E2 is equal to N1 upon N2, we will get the value of armature speed, EMF, armature voltage, and same is repeated for minus 500 velocity. And in the third part, firing angle is given 160 degrees, and sequentially we can get the display of armature voltage, EMF, and new speed. So this based on the programming, this graphical output between the armature speed and armature voltage is shown with X labeling and Y labeling, and also text message of speed voltage characteristics at the desired location with the marker shape as square and line as green color, and line shape is dash dot dash dot. So you can also do the 3D plotting for this. Okay, so this is for the enthusiastic students who are having the positive, getting the positive vibes. So for them I have also given the 3D plotting program of the same numerical problem. It is same, just at the end we will be tweaking some of these values till this n is equal to 1 ratio 1 ratio 180. And now we are plotting this plot 3. We will giving the values of v, a, e, and n. And since the firing angle is varying, so cos d is followed by the bracket and n is there. So e, EMF, and speed will take those values automatically. So 3D plotting command is plot 3 and then the 3 variables in which we are required to plot. So this 3D plotting is between the firing angle, armature voltage, and armature speed. Okay, so this we can get the output. This is 3D. So on the x-axis you can see the firing angle, on the y-axis you can see the armature voltage, and on the z-axis you can see the armature speed.